let's talk more proportions. So again, proportions are a fraction equaling a fraction or a ratio set equal to another ratio. And again, if we have three of the four pieces, we can find the fourth one, right? So I've done a couple videos on proportions already. You know the basic drill. But the nice thing about proportions, we can use them for a lot of different things. So before I jump into that, let's refresh just how do we solve proportions, cross multiply. So B times C can be set equal to A times D, right? So that's the nice thing. They are solved easily and we can use them in a lot of different ways. So this video is about using proportions to compare using rates. And the big key here is rates. Why is this important? Well, there are some numbers that are either way too big or way too small for us to really think about and be able to contextualize in our own heads. So think about if I said like 3.2 trillion. This number is way too big. There's no way that I would be able to comprehend. I don't care if that's Skittles. I don't care if that's ants invading your closet. I don't care if that's Christmas trees. I don't care what it is. It's way too big of a number for anyone to really contextualize and understand what that means. Similarly, if we have a number, let's just say like this, right? Super, super small, we also can't really comprehend what that number looks like. So we can use proportions to change these types of numbers and types of things into maybe like per 1 or per 10, per 100, because then we'd have a better way of understanding, right? So the point of using proportions to compare using rates is to allow us the ability to understand and comprehend these numbers in sizes that we can imagine, right? Okay, so let's jump in. There were 82,529 people in attendance at Super Bowl. I have too many words in there. And approximately 21,500 hot dogs were sold at this game. Now, if we just stop there, I can get an idea of what 82,000 people look like, right? Think about a football stadium. That's what we're talking about. And it's full. But I'm telling you right now, the idea of 21,500 hot dogs, I have no idea what that looks like, right? I know what 12 hot dogs look like. I've seen 12 hot dogs. I've probably even seen 30 hot dogs at a party, right, in a basket together. But 21,500 hot dogs, that's hard for me to understand what that looks like. So we can break this down and say, okay, how many hot dogs per person? So for one person, how many hot dogs would they have eaten? That gives me a ratio that I can comprehend. So let's set this up. I'm going to put hot dogs on the top, people on the bottom. All right. So I know that 21,500 hot dogs compared to 82,529 people. And I want to know how many hot dogs per person. Now, you might be saying right now to yourself, Becky, you're dumb. You don't need to use a proportion for this. I know, we could have just divided. We're getting there. Part of this is understanding how proportions work, because we don't always look at per one person. So sometimes it takes a little bit more work. So if you just humor me for a minute, if we set this up as a proportion, because we want to know hot dogs per person, let's refresh. We know that we can cross multiply and get 82,529x, and then 1 times 21,500 is just 21,500. Now, if we divide to get x by itself, and this is where you should be saying, Becky, you're an idiot, we end up with the same ratio, 21,500 over 82,529 that we started with. So if we just divide those two, we end up with 0.26. I rounded that. Now, what this tells you is that for every person at this Super Bowl, they ate approximately 0.26 of a hot dog, right? 0.26 is very close to 0.25, which is a fourth. So to give you a better understanding, every person in that stadium ate about a fourth of a hot dog. That gives you an idea of how many hot dogs were eaten. So a ton of people, well, 82,529 of them. Every one of those people ate about a quarter of a hot dog. I can see that. I understand eating a fourth of a hot dog. That's what was happening at this Super Bowl. Okay? All right, let's do another one. The population of Indiana is approximately 6.732 million people, And the state is home to 221 Starbucks. That's the last thing I could find on the internet anyway. Now, I don't know about you, but 221 Starbucks, 6.7 million people. I definitely don't know what that looks like. But I know 100,000 people, right? If I think of like watching Ohio State football, because I'm an Ohio State fan, Ohio Stadium holds just over 100,000 people. So if I fill up that stadium with people, how many Starbucks would serve the 100,000 people in that stadium? That's what I can think about, right? I can visualize a big football stadium, and how many Starbucks would that feed? Okay, so let's look at this. So if I'm talking about Starbucks, there's 221 Starbucks compared to 6,732,000. Okay, so that's 6.732 million people. So how many Starbucks for 100,000? Okay, so now again we cross multiply. So 6,732,000 x equals 100,000 times 221 is 22,100,000. And I want to get x by itself, so I divide both sides. Make sure that your numbers are a little bit nicer than mine. And then we end up with this ratio. When I reduce it down here and round, I get approximately 3.28. So if you think about taking the population of Indiana, and if we narrow it down to just fill up a football stadium, 100,000 people, right? So this is like Ohio Stadium or Michigan Stadium. There would be approximately 3 Starbucks to service all of those people. That's kind of the relationship between. And that is what proportion with rates can do. It just gives you the ability to understand and contextualize these problems so that you can better visualize what's going on. And it's not just these abstract big numbers that don't mean anything. All right. Thanks, y'all.